let me design the full adder. So how to write the full adder? So we all know that. So full adder, okay, full adder will be having the 3 inputs and the 2 outputs. So half adder was having 2 inputs and 2 outputs, right? So the full adder will be having 3 inputs. So let me write down the block diagram for the full adder. So full adder will be having the 3 inputs and 2 outputs. So the 3 inputs is A, B and C in. C in means carry in. So A, B and C in. So the outputs are sum and carry. So the outputs are sum and carry. So let me write the truth table for full adder. Okay. So how many number of inputs are there? So there are 3 inputs. So what will be your length of the truth table? 2 to the power of 3, that is 8. So now let me write down the truth table. A, B, C in. So carry and sum. So this will be your truth table. So 0, 0, 0. Next 0. So 0, 1. 0, 1. 0, 1. 0, 1. Okay. Next 0, 0, 1, 1, 0, 0, 1, 1. 4 zeros, 4 ones. So this is the easiest way to write down the truth table. So now, as I have already told in the previous half order concept, so 0, 0, 0 means what? If you are adding all these 3 zeros, the answer will be 0. So there is no carry here. So 0, 1, 0. If it is having only 1 bit, if it is having under the 1 bit position, if there is 1 bit, then obviously the answer is 1 and there is no carry. And now 0, 1, 1. If there are 2 ones in the 3 representation, 1 plus 1 is 2, right? So you know how to write the 2, right? In the binary that is 0 and 1. So 0 will be the sum, okay? And carry will be 1. Next 1, 1, 1. So 1 plus 1 is what? It is 3. 3, how to write it in the binary representation? It is 1 and 1. So sum will also be 1 and carry will also be 1. So this is how you have to write it for the full adder. I repeat it once again. If all the 3 bits are zeros, the answer is 0. That is sum is 0 and the carry is also 0. There is no carry. So if I am writing, if there is only a single 1, the sum is 1 and there is no carry is 0. Okay, if there is 2 ones, if there are 2 ones, the sum is 0 and the carry is 1. And if there are 3 ones, okay, for all the 3 ones, the sum is 1 and the carry is 1. So this is how you have to understand before filling the truth table. So now, so 0 plus 0 plus 0. What is the answer? The sum is also 0. Carry is also 0. Okay. Sum is also 0 and there is no carry. So therefore I am writing it as 0. Next 0, 0, 1. So if there is only single 1 in these 3 representations, so sum will be 1 and there is no carry. So therefore I am writing it as 0. So again the same is among the 3 representation or among the 3 bits or among the 3 inputs, only single 1 is there. So the sum will be 1 and the carry will be 0. So here there are 2 ones. So sum will be 0. See here, the sum will be 0 and the carry will be 1. Here a single 1 is there. Sum will be 1, carry will be 0. And here 2 ones. Sum will be 0 and the carry will be 1. And here 2 ones. Okay, 2 ones. So sum will be 0 and the carry will be 1. And there are 3 ones. So sum will be 1 and carry will be 1. Just observe this. 3 ones is there. 3. Binary representation of 3 is double 1. See here, binary representation of 3 is double 1. So therefore I am writing sum is 1 and carry is 1. I hope you have understood the truth table. By referring to the truth table, we have to write the K-map, and from the K-map you will be getting the expression. Once you are getting the expression, it will be very easy to write down the circuit diagram. Okay. So now I will write down the K-map for sum and carry. Okay. So now I have to consider a 8 variable K-map. Okay. Have to consider the 8 variable K-map, that is A, B, C. Since there are 3 variables, you have to consider the 8 variable K-map. So here comes 0, 1, here comes a 0, 0, 0, 1, 1, 1, 1, 0. Okay. So what is the cell numbers for this? 0, 1, 2, 3, 4, 5, 6, 7. So this is the cell numbers for the K-map. Okay, now let me write the K-map for sum first. Let me write the K-map for sum first. So now 0 of the cell has to be filled with 0, and the first cell with 1, second cell with 1, third cell with 0, fourth cell with 1, fifth cell with 0, sixth cell with 0, and the seventh cell with 1. So if you just observe the numbering, I mean the binary representing in the K-map, so do you have any possibility for octet? Not possible. Do you have a possibility for quad? No. And for the pair also it is not possible. So therefore, obviously you have to go for the isolated one grouping. So this is the grouping that you will be getting. So what is the expression for this? So it is A, and if you just look here, it is B bar and C bar. And what is the expression for this? It is A bar, see here it is A bar, B bar and C. What is the expression for this? It is A, B, C. For this it is A bar, B and C bar. So this is the expression that you have getting for sum. So let me write down sum is equals to A into B bar into C bar plus A bar into B bar into C plus A into BC plus A bar into B bar, B into C bar. So now if I just consider this, so I can take A common from these two things. Okay, I can take A common from these two terms, and I can take A bar common from these two terms, right? So let me take A common from these two terms, which are these two terms. If I am taking A common, it will be coming as B bar into C bar plus BC. Okay, if I am taking A common from these two terms, we will be getting as A bar into B bar into C plus B into C bar. So this is what the expression you are getting if I am taking A common from these two terms, and if I am taking A bar common from these two terms. Okay. So now, as I have already discussed with you, what is the expression for the XOR? So the expression for XOR is Y is equals to A into B bar plus A bar into B. So this is the expression for XOR. Okay, when I was discussing about the derived gates and universal gates like AND, OR, NOT and universal gates, I have already given the expression for the XOR. So this is nothing but this, right? This is nothing but this. See here. So B bar into C plus B into C bar is nothing but the XOR operation, right? So what about this? B bar into C bar plus BC is nothing but XNOR operation. So this is XOR. Okay, this is XOR. And what is XNOR? XNOR expression is Y is equals to AB plus A bar into B bar. So that is nothing but Y is equals to A dot into B. So this is how we are representing for XNOR. Okay. So this is XNOR operation and this is XOR operation. Okay. So now what I will do is I just take this as, okay, I'll just write it this as B into XNOR. Can I write it like this? See here I have shown for AB combination. Here it is there for BC combination. That's all. So B XNOR C. Okay, plus A bar. So what is this? This is B XOR C. See here it is B XOR C combination. So this is XOR and this is XNOR. And one more thing what I can write is A into XNOR means what? If you are giving the complementary for XOR, you will be getting XNOR. I repeat once again. If you are giving a complementary for XOR, you will be getting XNOR. So now can I write like this? B XOR C, the whole complement. Can I write this as like this? Plus A bar B XOR C. So this is the expression that you are getting. So now, okay, shall I erase this? I'll erase this part. Okay, I'll just erase this part and I'll start writing from there. So A into B XOR C whole bar plus A bar into B XOR C. Don't be confused. Okay, just I am copying the same. So now let me take this as X. If I am taking this as, so let me take this as X. If I am taking this as X, obviously this will become X bar, right? So now my expression is A into X bar plus A bar, okay, A bar into X. So this is what my expression has arrived for sum. Okay, so this is what the expression that you have arrived for sum. Okay, keep this in mind. Okay, keep this. Okay, write down this in your notebook. After writing the circuit diagram after writing the K-map for carry, then we will write the circuit diagram. Okay, till here everyone has understood. I repeat it once again. Just write down the truth table for sum and carry, and write down the K-map and fill the cells by just copying the representation from the truth table into the K-map. Then write down the expression for each and every group. So now I have made a small simplification in order to make my circuit diagram to look very neatly. Okay, in order to make my work a little bit easier, I have made some simplification. Okay, so till here I have arrived. By taking this expression, I will write my circuit diagram. So later on we will see. So now I will write the K-map. Now I write the K-map for carry. Now I will write the K-map for carry. So carry. So this is for carry. So this is A and this is BC. 0 1 0 0 0 1 1 1 0. So 0th cell, first cell, second cell, third cell, 4th cell, 5th cell, 6th cell and 7th cell. So now if you just copy it from here, 0th cell is 0, first cell is 0, second cell is also 0, third cell is 1 and 4th cell is 0, 5th cell is 1, 6th cell is 1 and 7th cell is 1. So now how to group it? So obviously there we cannot go for an octet, we have to go for quad. Since there are 4 number of ones, is all 4 number of ones continuous? No, so therefore we cannot go for quad as well, we have to go for pair. Okay, so this is one best pair that you can easily write it. Okay, and this one is left out. So I shouldn't go for an isolated one because you have the possibility to go for pairing. So therefore I go for pairing like this. Okay, so these are the 3 groups that you can do it and easily write down the expression for all these terms. Okay, so what is the expression for this? It is A and it is C. So what is this? A and B. And what is this? It is just BC. So what is the answer for carry? So answer for carry is AB plus BC plus CA. This is the expression that you are getting for carry. Okay, I will write it here only. Okay, for carry expression is AB plus BC plus CA. So this is what the expression that you have got it for carry. Okay, I write down very neatly this one. Okay. So in the next video, I will be explaining how to write the circuit diagram by making use of these 2 expressions. Okay, just copy down these 2 expressions for sum and carry. Then later on we can write down the circuit diagram for